Welcome to Ask Geology, a whole new way to understand Mother Earth. So, in this today's session, we will be discussing about one numerical related to your geophysics. This is the second numerical. If you have not seen the first numerical, you can check it in the playlist. So, the question is the difference in arrival time of P and S wave generated by an earthquake and recorded at a seismological station is 1 second. Assuming a homogeneous and isotropic Earth, a P wave velocity is given to be 3 km per second, and the ratio of P to S wave velocity is 2. Okay, the distance between the station and the hypocenter is dash kilometer. Basically, it is asking about the epicentral distance. Okay, so let's see when actually earthquake. Why this earthquake happens? What actually earthquake is? This is basically is the sudden release of the stored energy, elastic energy. Okay, so in case of, we can see that faulting also generate some release of your strain energy. This is elastic energy, or you can call it as strain energy. Okay, strain energy. So basically what actually happens when earthquake happens, then it basically releases some amount of energy, and the energy gets propagated by various means. There are so many of elastic waves, the body waves and surface wave. Body wave and surface wave means, body wave means that will propagate through the body, and surface wave that will propagate through the surface of the earth, or up to some depth, 2 to 5 meter depth. Okay, body wave, the P wave and S wave. Body waves, we'll be discussing about these things later. Okay, so this, and you can see this is the epicenter, this is the focus, the actual original point for or of the generation of your earthquake is focus, and directly on the point present above the focus on the surface of earth, that is your epicenter. And this signal, okay, this energy, strain energy, it will go from this place to this is your seismic station. Okay, this is your seismic station. So it will go to the station. This is the surface, this is the body wave, and this distance, this is called your D, or this is your epicentral distance. Okay, so in this question, what are the given fact? Let us see. P wave and S wave, then the difference Ts minus of Tp is given to be 1 second. Okay, and the Vp, velocity of P, is given to be 3 km per second, and Vp by Vs they have given is equal to your 2. So from this we can calculate the velocity of S wave, that is Vs is equal to, this is 3 by 2, this is kilometer per second. Up to here this is clear. And for the calculation of your epicentral distance through the travel time difference, we have one simple formula to calculate this one. This D is your epicentral distance in kilometer, this is your epicentral distance in kilometer, and P, Vs, these are velocity of P wave, velocity of S wave, and Ts minus Tp, this is the travel time difference. This is your travel time difference to reach the seismic station. Okay, so we can use very simply what are the given values. Okay, so I'm using here this space. Okay, so Ts minus Tp is given to be 1 second is equal to D, we have to calculate because it is asking D is the epicentral distance, and 1 by Vs, you can this is 3 by 2, so this become 2 by 3, minus of velocity of P wave is equal to 3 km, then 1 by 3. So simply we have to simplify this one. That implies 1 second is equal to D into, then you take the calculation part, you can do divided by 3, so you can get here this is equal to 1 is equal to d into 2 minus 1 is equal to 1 by 3. So simply d is equal to 3 kilometer. So our answer here is 3 kilometer, and d epicentral distance, this is expressed in kilometer. Okay, so from this point we can just derive another formula. If ts minus of tp is given, okay, that is ts minus of tp, that is the travel time distance is given. So if I just want to just calculate it in terms of tp or ts, okay, tp or ts, so what can I do? Like, if I just add and multiply and divide with the vp divided by vp, then what will happen? 1 by vs minus of 1 by vp. So the formula becomes d by vp, this d by vp is equal to tp. This is the travel time of the p wave, the time taken the p wave to reach the seismic station. Then I can just take the vp inside. This is your vp by vs minus of vp by vp. This is basically the like subordinate, like we can extract this type of formulas from this, which can be directly be used. Okay, so this becomes tp vp by vs minus of 1. Okay, and this can be written, this is ts minus of tp is equal to tp if velocity of p wave is alpha and velocity of s wave is beta minus of 1. So this is basically expression of your travel time distance with the, like, if the given the velocity of p wave, travel time of the p wave is given instead of your epicentral distance, then this formula can be used. Okay, and we can also calculate for ts, then what will be happen? 1 minus of beta by alpha, that will be one another formula. Okay, so here in this case we are getting the answer to be your 3 kilometer. Okay, and what are body waves and what are actually body waves? They propagate through the body, and there are two types of body waves, p wave and s wave. This is basically your p wave. Okay, the properties you can see, this is your p wave, always arrives, this is the fastest wave, arrives first in the seismic station. Okay, its velocity is fastest. Okay, particle motion in the direction of propagation, you can see this is the direction of propagation, this is compression and rarefaction. It can propagate both in solid, liquid and gas. And in case of S wave, you can see that the particle motion under the influence of in the direction of energy applied in and perpendicular to the propagation, you can see that the particle motion is perpendicular and this is the direction of propagation. You can see this is the perpendicular. Okay, it can only propagate in solid. Okay, there is no compression expansion to the particle motion and thus no pressure disturbance. This p wave is basically a pressure disturbance or pressure wave. Okay, and one can detect S wave through the measurement of particle motion. That is different. So and surface wave we can get the lobe wave and relay wave. Okay, or particle motion consists of alternating transverse motion in lobe wave, you can see that, and both the lobe wave and the relay wave, you can see that the with respect to depth they decreases. Okay, the intensity decreases. The particle motion consists of alternating transverse motion. It is horizontal and perpendicular to the direction of propagation. This is transverse, you can see that. Okay, this is the particle motion, purely horizontal. And in the relay wave, it is found in 1885 Lord Relay. Okay, and wave rolls along the ground just like a wave roll across a lake. This is retrograde elliptical motion, you can say retrograde motion. This is your prograde, this is your retrograde, this is anti-clockwise motion. Okay, so this is all about today's class. Thank you. If you want to join our group, then you can text to these numbers, and thank you.